So now let's apply the idea of segment addition to a few examples using algebra. In example 4, they tell us that M is between points K and N. First thing you would want to do is always diagram that. I have points K and N with point M in between. Again, it does not matter where in between as long as M is in between. Then I want to label what I know. I know that segment KM has a length of 2x minus 4. That segment MN has a length of 3x. And that the entire length from K all the way to N has a length of 26. So that's me drawing a figure representing the situation and making sure I label it accurately. From here, I want to find the value of x in order to know what the lengths of segment KM and MN are. This is segment addition. I know that this small piece plus this small piece is going to equal the entire length, which is 26. So the equation I can set up is 2x minus 4 plus 3x, small piece plus small piece, and set that equal to the entire length of segment KN, which is 26. And now I use my algebra to solve for x. 2x and 3x are on the same side. I get 5x. If I add 4 to both sides, I get 5x equals 30. Divide both sides by 5, and x is equal to 6. That doesn't answer my question, so I will be putting my final answers here. But I'm not ready to do that quite yet, because I can't know what segment KM's length is or what segment MN's length is until I plug that 6 back in for x in both situations. So I know that KM is 2 times 6 minus 4. Well, that's 12 minus 4. KM has a length of 8. And I know that MN has a length of 3 times 6. Well, MN has a length of 18. 8 plus 18 is 26, so I know I'm right and I have not made a mistake. Example 5 is set up for you already. We don't have to label or draw anything. We just want to see that I have two small pieces, segment IJ and segment JM, and when I add those two together, it will equal the length of the entire segment IM. So, my equation, small piece 3x plus 2, plus my second small piece 18, equals the length of the entire segment, 5x. Again, it becomes an algebra problem at this point. So what my main focus here is solving. I'm going to go through the solving quickly, expecting that we know how to do this. I'll show a few more steps here. This time I'm going to subtract 3x from both sides. I do that simply because 5x doesn't have any constant term with it. I don't want to eliminate any side. While I do that, I'll combine like terms on the left. 2 plus 18 is 20. 5x minus 3x is 2x. So when I solve for x, I find that x is 10. That's one thing they wanted me to do. Now they want me to find ij, no bar above it. That means find the length of ij. So 3 times x, which is 10, plus 2. That's going to give me ij. 3 times 10 is 30. 30 plus 2 is 32. There's my final answer. Example 6 is the first example of the semester where we are going to be using algebra that is going to involve solving a quadratic. So, the concept is the same. I have segment FG, that's one small segment, it's 3x, plus segment GH, another small segment, that's x squared. equals the length of both of them combined, which is 10. So those of you who've struggled with algebra in the past, pay close attention to what we're talking about here. We talked about solving a quadratic. We know we have to do it because we have x squared and x in the same equation. This is when we're going to use the zero product property. So 0, which means my equation needs to equal 0. Product, which means I need to have two binomials multiplied together. And then I can use this property, which states that this first binomial must equal 0 or the second binomial must equal 0. So first thing I need to do here is make this equal to 0. I'm going to subtract 10 from both sides. That guarantees that the equation equals 0. Before I go and just write everything down on the left, keep in mind we need this in standard form. That means my x squared term must come first. I have a positive x squared. That must come first. My 3x is also positive, so I will write it as plus 3x. I'm subtracting 10, so it's minus 10. This is my 0 step in the ZPP process. Once that's done, I can now try to find my product. When I'm finding my product, that's when I am writing this as x with something times x with something else equals 0. This is what we discussed in class during our review. I'm going to take my constant term. In this case, it's a negative 10 and put that on top. The coefficient of my x term, in this case it's a positive 3 on the bottom. The numbers on the side, I am looking for them to, at the same time, multiply to a negative 10 and add to a positive 3. So go ahead and take a second to see if you can figure out what those are. Hopefully, you have found that 5 times a negative 2 will give me negative 10, and 5 plus a negative 2 will give me a positive 3. Those are the factors I add into my binomials here. I do x plus 5 since the 5 is positive, x minus 2 since the 2 is negative. That's the product portion of the ZPP process. Now that I've done those, I can apply the final property, which says that this first binomial, x plus 5, must equal 0, or the second binomial, x minus 2, must equal 0. Go through the process of solving, and we get x equals negative 5, or add 2 to both sides, x equals 2. If that went too fast for you, you can go ahead and rewind and watch it again. But we're not done. If this were an algebra class, we would be done. We would circle or box all of this in and say, that's my final answer. Because we're in geometry, we must check. Because we're dealing with segment lengths here. We're not dealing with just an equation. I need to make sure that it makes the numbers that we get as our answers make sense as my segment lengths. By that I mean this. If I plug negative 5 in for x, 3 times negative 5 is negative 15. Negative 5 squared is 25. If I add those together, I do get positive 10. But this right here does not make sense. We can never have a negative segment length. Be careful. You can have a negative variable, but your segment length cannot be negative. Since negative 5 makes that segment FG negative, it's not a solution. If I put 2 in for x, 3 times 2 is 6, 2 squared is 4, they're both positive and they add to 10, that is a correct solution, whereas x equals -5 is not.